Hi everyone, I'm Linlin from Shenzhen University. Today's topic is activation template matching logs for explainable face recognition. Okay. For for explainable face recognition, the key problem is what face recognition network had learned. The figure A shows the visualization method can for object classification is clear to show the attention of the model when it made a decision. And figure B shows the same visualization for face recognition, but it shows the attention cover whole face, so it's unable to provide fact information about the model had learned. And the figure C shows the feature map of a VGG net for face recognition. As we know, it should be a random pattern due to the displayer extract dimensional feature that our human don't understand. And figure D shows the feature map of a VGG network. Chain with our method it's able to explain what face recognition network had learned. So in this study, we propose a generic explainable channel log CC logs to construct an explainable face recognition network. The explainable network chain with EC log can easily learn the facial part-based representation on the target convolutional layer when an individual channel can detect a certain face part. As shown in the figure, a figure of the explainable a channel of the explainable face recognition network chain with EC log can learn semantic part like eyes, mouth, and nose, and so forth. To the best of our knowledge, this is the first method to construct a feature-level explainable face recognition network that does not require any additional data set or manual annotation. In this way, the explainable network is able to effectively demonstrate what had been learned. So the main goal of our method is to construct the feature map to a known pattern, and for each feature map contains at most two activation P's. As shown in the figure, the latter column show the random activation in the feature map, and after training with our EC logs, the feature map can effectively demonstrate what had been learned. So first, we define a template with an activation P as this slide. The value of P is tau, and the value of other pixel is stand outward by equilibrium distance until negative tau. In order to match activation P with our face part, we allow a feature map to contain at most two activation Ps. We define a set of one P template and two P template. It is combination of one possible P and two possible Ps finally plus a negative template. The activation template have following property: include all possible position of activation P, and it can force each channel of feature map containing at most two activation Ps, and it can match each channel of feature maps to one of the activation template. Then we define a set of feature map X. Then we can use the concept of mutual information from information theory to define a mutual information between our template T and feature map X. Then we can get this formula after some transformations. Then we define a problem given a template set of activation pattern T and the feature map X of the target convolutional layer from the face recognition network. The tag of mutual information X and T is to find the parameter theta such that feature map X maximally represent the activation template set T. And as we know, before training, the feature map is a random output when the input face image goes through the network. So the feature map X and the location of all face parts are unrelated. Therefore, the feature map X and the activation template T are independent. So the mutual information between X and T approach to zero. And during the training, we propose EC log is applied to the last convolutional layer of the network to increase the mutual information between X and T. As a result, after training, the pattern of the feature map X will match the activation template T. Finally, we define a total logs to be alpha times classification logs plus beta times our EC logs, where alpha and beta are weighting coefficient and the EC log is negative mutual information. Then in order to match activation P with feature peaks with face parts, we allow a feature map to contain at most two activation peaks, we define the 2P template to be combination of any two 1P, 1 peak template. Okay. And for dataset, we use link 360,000 as training data and this 10 dataset to be the testing dataset. This figure shows the visualization for top 10 activation. The activation piece of an individual channel tends to be located in the same face part, and each channel of feature maps contain at most 2 activation pieces. For example, the second channel learn the mouth and the 122nd channels learn the right eyes. So for the network chain without easy locks, all the feature maps are activated by random pattern, and its activation P had no specific meaning for face recognition. And this is the comparison of the feature map between network with without easy locks. For the same input phase, the feature map of the explainable network chain with easy lock had at most 2 activation Ps and usually activate a certain face part instead. Instead, the feature map of the original network had more noise, and the activation Ps are located randomly on the different parts. And this is our experiment result. Face recognition may compute the similarity between a reference and a probe face image to decide if these faces are of the same identity. Our method reached a higher accuracy than original method. Parse explainable is an evaluation metric on explainability in which it measures the object part explainability of channel from the network. We got a higher part explainability than the original method. Located consistency, which indicate whether the channel of the feature maps is able to detect the same face part regardless of the input image. Our method also performed better than original method. And the purpose of the activation robustness is to evaluate the average number of P's in the feature maps. It shows our method can effectively reduce the number of activation P's on the feature maps. Our experiment had showed that our proposed easy lock can achieve significant explainability metric while improving the performance of face recognition, but there are some limitations. It needs more memory and training time than original method, and there are many hyperparameters to set manually. Okay, that's all. Thank you.